Okay. What kind of mirror is this and what kind of mirror is this?
The first one on the left-hand side is a concave,
Great.
and the other is a convex.
Great. Okay. So first we will see the first topic is laws of reflection. Have you went through the that uh, handouts that you were given?
No, ma'am.
Okay, it's fine. Okay. First we will see the laws of reflection. What is reflection? What is light? First we will see what is light because the chapter is light. What is this? This is a form of energy, right? That enables us to see anything,
Yes, ma'am.
right? Light is the form of energy that enables us to see any object. Okay. Actually, when light, the object, how can we see the object through light? Means what happens that we start seeing the object when it's dark, then we can't see the objects, right? And when there is light, then we can see the objects. How?
This is a light rays falling on the area.
Yeah, actually, the object reflects the light that falls into it. Reflects the light that falls into it. And that is why we can see the object. Okay, fine. So here what we are seeing, light is a form of energy that see. Light is a form of energy that enables us to see. An object always reflects the light rays that falls on it. These reflected light rays, when received by our eyes, make the object visible to us. So these reflected light enables us to see the object that is in front of us. Fine. And speed of light. What is the speed of light? Light has the maximum speed, right? What is the speed of light? That is 3 into 10 power 8 meter per second. Okay, 3 into 10 power 8 meter per second. Okay. Now we will see what is reflection of light. Just we have seen just we have see the formula of light. Sorry, formula not definition of light. That is, light is a form of energy that enables us to see the object, and object reflects the light. So what is reflection? What is reflection? Reflection means the bouncing back of the light. When the light bounces back, right? When the light bounces back, its rays in the same medium, means like this. Suppose this is the surface of any object, and light falls into it, and again bounce back to the same medium. Suppose this is the medium, this is air, and this is glass. Okay, this is air and this is glass. So when light falls into it, and this is called normal. Normal means 90 degree. The rays which goes 90 degree, which form 90 degree with the object, it is called what? Safia, are you there?
Yes, ma'am.
Just now you joined.
Yeah, there was some connection problem.
Okay, you're from Bhadoi.
Yes, ma'am. I'm at the Vadoi Center.
You are at the Bhadoi Center. Okay, fine. So, what is normal? Normal is the ray of light that falls on the object normally. Normally means forming 90 degree with the object. Okay. So, this is also a light ray. But this is called normal. Why this is called normal? Because it forms 90 degree with the object. Fine. So, we draw this normal, and then a light ray comes making an angle of theta, whatever that theta may be, angle may be. So, and bounce back to the same medium, So, this is called reflection. Okay. This is called reflection. Fine. So the phenomenon of bouncing back of the light ray in the same medium on striking a smooth surface, this is called the reflection of light. This is what we just did here in this diagram, that this is our surface, this is normal, this is light ray that is falling onto the surface, and with some forming some angle with the normal, and bounced back to the same medium. Okay, and this is called the reflection, and this angle will call the angle of reflection. And from here, when the and the laws of reflection says that angle of incidence is equal to the angle of reflection. Angle of incidence means this is the incident light that falls on the object. Fine. Incident ray. This is called the incident ray. This is called the incident ray that falls on the object. Incident ray. And this is called the reflected ray that bounce back to the same medium. Reflected ray. Okay. This is called the reflected ray, and it goes to the same medium and forms, and the angle of incidence is always equal to the angle of reflection. this comes under the laws of reflection. Just now we will see what is laws of reflection. We have went through the topic of reflection. Now we will see what are the laws of reflection. There are two laws of reflection. Safia, have you been taught in the school this chapter?
Yes, ma'am.
Oh, means this chapter has got finished.
Yeah, we've done the reflection part, but not the refraction part.
Okay. Okay. Can you can you tell me that which mirror is this and which mirror is this?
Ma'am, the first one is a concave mirror and the other one is a convex mirror.
Very good. Most of the students get confused in this now. So this is why I asked you whether you people are aware of this or get confused. So laws of reflection. There are two laws of reflection. First, the angle of incidence is always equal to the angle of reflection. Okay. Angle of incidence is also always equal to the angle of reflection. Fine. And the second says that the incident ray, the reflected ray, and the normal ray all lies in the at the point of incidence. At the point of incidence, all lie in the same plane. I will tell you what is this. In the same plane. Okay. The incident ray, the normal ray. See here. Here we have incident ray. Here we have reflected ray. Here we have normal ray. At the point of incidence, see, all all rays are coming to the same point. Either coming to the point or emerging from the point. All are from the same point, right? All are lying in the same point and are in the same plane. This is the plane. This is the plane now. We are seeing the plane, right? This is the plane. All are lying in the same plane and at the point of incidence. Incidence means where the light is falling onto the surface. Means this. This is our surface. When the light falls on it, this is called incident ray, right? This is called incident ray. Incident ray. From wherever the light falls, at whatever the point light falls, we draw the normal from that point. This is our normal, okay? And from where the light, wherever the light is striking onto the surface, it bounces back from the same point. It bounces back from the same point. That is making reflected ray. Reflected from the same point. So this is called the angle incident ray. This is called the reflected ray, and this is our normal. All are at the point of incidence, and all are lying in the same plane. This is our second law of reflection. Fine. And first law was the angle of incidence is always equal to the angle of reflection. And always take angle of incidence and angle of reflection with the normal, not with the surface. Not with the surface. Okay? Not with the surface. So don't get confused about where to take the angle from. You have to take the angle forming with the angle of incidence and normal for angle of incident ray and the normal for angle of incidence, and normal and the reflected ray for angle of reflection. And here we can see, not writing this theta, we can write here an angle of incidence and angle of reflection. So angle of incidence is always equal to angle of reflection. This is our first law. And this is our that all lying in the same point, at the same point and all lying in the same plane. This is our second law of reflection. Fine? Is it fine? Up to this? Up to this, is it fine or not?
Yes, ma'am.
Anyone? Okay. Now we'll see what is regular and diffuse reflection of light. Regular and diffuse reflection of light. Regular and diffuse reflection of light. What is this? Anyone? Any guess that you people can make? Any guess? No? Okay. Regular and diffuse reflection of light means when the light falls on a smooth surface, then there is a regular reflection of light. But when the surface is not smooth, is not unpolished and rough surface is there. If the surface is not smooth and it's rough, then the reflection that we experience is that the light experience is diffuse. Means there is an irregular reflection of light, like this. This is our regular surface. Okay, this is our regular surface. This is our regular surface. So when light falls on it, then we experience a regular reflection of light. This is the angle of incidence. This is the incident ray, and from at the in which point the light is striking the surface. So we will draw the normal from that point only. Okay, This is our normal. And reflection. This will get reflected. This R. If angle of incidence is like this, then again we will draw normal from this point. This will be our normal for this incident ray, and this will be our reflected ray. Okay, this will be angle I, this will be angle R, and this will be angle I for this incident ray. This will be angle R. Okay, we are getting here a regular reflection of light. But when the surface is like this is not smooth. So this is not smooth, not regular. So when incident ray falls upon it, we get irregular reflection of light, diffuse, or you say diffuse reflection of light, not like this. You can get like this. Okay, when we are getting this, you can get like this. We are getting this, you can get like this. Is it smooth? You people can unmute and say
No, it's
hello.
not smooth.
Okay, we can see from this image also that here the light is experiencing regular reflection, but here it is diffuse reflection because the surface is not smooth, it's rough. So here angle I, this is R, and it's not making the same angle. Somewhere it may make the same angle, but most of the time it will not make the same angle. Like this look at this light. It's getting incident here at this point, and then getting reflected where, making such a there is nothing like the angle will be equal or something like this is not regular reflection, right? And here we are seeing that it's smooth, regular, and reflection is totally smooth. Fine. So if the surface will be plain, then the light's reflection will be smooth and irregular. And if the surface will be rough, then it will be the reflection will get diffused. Fine. Now, when we talk about reflection, then we have to talk about image. Because when you see the plane mirror, when you see your plane mirror, you see. Do you people see mirror? Do you people see face on your on mirror on see your face on your on mirror?
Yes, ma'am.
Yes. So is it you inside the mirror or your image?
No, not image.
Your image, right? So when we talk about reflection, we have to talk about image. Okay, it will because mirror makes the image. So whatever kind of mirror it will be, either plane or spherical. Okay, it forms image. Image are of two types. When we talk about image, it's of two types. One is real and another one is virtual. One is real and another is virtual. So real means what? Real means how the image is real and how it's virtual. When the rays of yes, Ruth?
From a real image is formed when light rays pass through the mirror and diverge from the image point.
Can you come again?
The real image is formed when the light rays pass through and diverge from the image point.
And virtual image?
And that's formed when the light rays do not pass through the image point but appear to diverge from the point.
Appear to meet, right?
Yes.
Appear to meet at another point.
Yes, ma'am.
And real image actually meet after reflection. Means if the light rays coming from a point actually meet after reflection. If there is if it meeting actually after reflection, then the image is called a real image. And if it is making it might appear to meet, it's just appearing to meet at another point, then the image formed is called a virtual image. Fine, we can take the example note. We will just see from the spherical mirrors maybe how the image is getting formed and how it's real and how it's virtual. Fine. So generally, concave mirror forms what kind of images? Concave mirror forms mainly real images, and virtual images formed from convex mirror. Okay, but in one case, concave mirror forms virtual image also, that we will study. Okay, so first we will see what is few of the properties of plane mirror. Just take a look about plane mirror. Okay, so image we have done image. Now plane mirror. Like here, mirror is a polished surface which reflects almost all the light incident on it. Mirror are of two types. Okay, mirror is a polished surface which reflects almost all the light incident on it. Whatever the light get incident on the this mirror, so it reflects almost all of the light. Fine. So this is called mirror. Now we'll see the plane mirror. What is plane mirror and spherical mirror? So there are two types of mirror. One is plane and one is spherical. Fine. So plane mirror, we will see plane mirror first, and then we will see what are the spherical mirrors. So plane mirror means this always forms the virtual image of the object. When we see the object is erect. Erect means, you know what? Erect means this, and inverted means this, upside down. Right? When the image is formed erect, means means our what we how can I define the erection? Your head will face the head and your toe will face the toe. Fine. When the image object's head faces the head and toe faces the toe, or you say feet, whatever. Feet faces the feet. Okay, object not image. When we see that image, head faces the head and feet faces the feet, then the image is real. Sorry, erect. Okay, then we say that the image is erect. And whenever we see the image is erect, then always it's necessary that the image will be virtual. Okay, if the image is erect, then the image will be virtual. And if the image is inverted, if the image that is forming inverted, then it is what? Then it's what? Real. Fine. Means erect image is always virtual and inverted image is always real. Okay. So plane mirror always forms your erect image. Is it or not? From whatever distance you see the plane mirror, it always forms your erect image. Your head always faces the head and your toes always faces the toe. Is it or not? Or you get or you can see your inverted image in the plane mirror. Do you see, Safia? Have you ever seen your inverted image?
Ma'am, in a mirror we can see laterally inverted.
Yes, laterally inverted, but not upside down, right? Not upside down, no?
Ma'am, like sometimes if we look at the surface of a spoon, we can see an inverted image.
That is not plane mirror. I am talking about plane mirror. Plane mirror forms laterally inverted image, but not the upside down image.
Yes, ma'am.
That is actually you when you see the spoon, that is actually making your means concave mirror and convex mirror. The size of the image and the size of the image is equal to the size of the object. Is it or not? When we see the plane mirror, I'm talking about here plane mirror. Okay, so in plane mirror, the size of the image is equal to the size of the object, and also your distance from the image, whatever be the distance of the image, or your distance from the mirror will be, you will experience the same distance from the of your image from the mirror. You'll not see if you are standing very far from your mirror, and you can see the your enlarged image or something like you are very close to the mirror. So it's not like that. If you are standing far from the mirror, then you will see that get image is also forming at the same distance from the mirror. Okay, but it's forming behind the mirror. Means like inside the, like, this is your plane mirror. Sorry, this is not plane mirror. This is your plane mirror. So if you are standing here, so you will experience the same image. Your image will be what? Erect. Your image will be erect and at the same distance from the mirror. Like this is X, so this will also be X, and image will also be of the same height. If this is H, then this will also be H. Okay, so but this will be erect and virtual. Erect and virtual image will form. Okay, distance between the image and the mirror is equal to the distance between the object and the mirror. This is what I told you just now. The distance will be the same, like X and X. Okay, distance between the image and the mirror. Image and the mirror means this image and the mirror, and is equal to the distance between the object and mirror. So this is the distance between object and mirror. Okay, so this will be same. The image is laterally inverted. Left seen to be right, and vice versa. because in plane mirror we experience our image as laterally inverted. Okay, when we lift our right hand and we will see in front of and stand in front of the mirror and lift our right hand, we will see that our image is lifting its left hand, right? So this is called laterally inverted. Laterally means xy, not in y direction, but in only x direction, right? Only minus x is becoming x plus x, and plus x is becoming minus x. Okay, so it's getting laterally inverted. The image is laterally inverted, left seems to be right, and vice versa. Focal length of the plane mirror is infinite. Its focal length is infinite. Fine, we will see what is focal length when we will study spherical mirror. This actually is focal length. Actually, is when we will study the about spherical mirror, then we will come to know that what actually is focal length. Because in this plane mirror is just means this is just a line, right? This is just a line, and when we will draw a spherical mirror, then it's forming a sphere. Means it's looking like it's it's a part of some sphere. It's a part of some sphere, right? And a spherical mirror is just a part of a sphere, no? So, and sphere or circle has always a center, right? It always has a center, and center the distance between the this center and this means this radius. This is called the radius, right? This if this is your center, this is called the radius, and the half of the radius is what our focus. This is called focus, and this is called the focal length. This is called the focal length. And when we talk about plane mirror, then it's not a part of sphere. Is it the part of sphere? Has it some any kind of center? No, right? Can a line have a center? Can a line have a center?
No, ma'am.
No, no. I'm not talking about midpoint. I'm talking about center. Line cannot have center. So, so this is why its focal length is infinity, because if it's if it is not having center, then how can it have, then how can it has focus or focal length? Because the half of the radius is focus, and the length between length of the point of focus from the this point means where the what we say this to the circumference of the circle. So what will be the this is called the focal length. So this will have focal length, certain focal length, or even this will have focal length. This might have a very big uh, this might is a part of very big circle, and it might have very larger radius. Okay, larger radius and also larger focal length. So if you if we are going to do like exceed the exceed this sorry, reduce this curvature, then and reduce this curvature to this part and then to this part, means it has become plane now. Now it will not have any kind of focal length or focus, because it will be, because we cannot judge of what circle is this the part, right? Because this is not the part of this, this is the plane. Fine. So we see about spherical mirror and radius of curvature that I told you about this radius in the next class. Okay, now the time has got over. So we have done our intro to reflection of light. Okay, this was just an intro, short intro. In this, we will have to study spherical mirror, means convex and concave mirrors, and for how the image is forming from concave and convex mirror, and also the what lenses. Okay, means refraction. We will go through some of the examples. So in the next class, please go through the handouts that you have been provided. Okay, fine. Should we close?
Yes, ma'am.
Okay. Okay then. Bye for today.